Okay, hello everyone. How did everybody find that? Hopefully it wasn't. It was okay. Good. Bit of an experience for me. Yeah, so we'll go through really super quickly. I'll write up a good answer. So, you know, this will be a bit quick and brief, but we'll just go through it really fast. Yeah, cool. I'm glad Aiden said it was okay. Got one person saying it's okay. I'm happy with that. Okay, so I'll just try and share my screen, guys. Okay, if anyone's brave and they want to say what they think the answers are, please feel free to shout it out. We'll go through one at a time. Have any questions, please ask, but you know, we're pretty limited on time, so we'll try and be quick. So we've got three sets for question one. We've got the universal set, the universe, x is an element of the positive integers such that x is less than or equal to 10, and the sets x is an element of u such that x is greater than 7 and b equals 1, 2, 3. So only tricky thing in this one should be that a is defined in terms of u. So I always used to hate it when people ask questions where one depended on the other one being right, but I'm sorry. As soon as I said a question, I do it myself. Anyone want to be brave? I'll just write it out. Anyone want to have a guess? So element of the positive integers, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. I would have been happy if you'd gone. I did say explicitly, but if you did the ellipsis, I wouldn't be upset. That's fine. Cool. Okay, so elements of A. So we said A is an element of U such that x is greater than 7. So this should be an easy one. As long as you got U correct, you should be fine. 8, 9, 10. Hopefully that's clear. So now, this one, what is again, I'm dumb. I always think of this as a little n, so I remember that it's an intersection. What is the intersection of A and B? I need a pen to write this one. Empty set, good. So, cool. So there's nothing, they don't intersect. They intersect with the null set. So what is the union? So again, being pretty brain dead, the union of A and B. So that's easy. That should be the set that contains 1, 2, 3. That's B, and A is 8, 9, 10. Cool. Next one. So AC, remember, is the complement. Oh, need to do a superscript. Okay, so that's the complement. So that's everything not in A that's in the universe. So again, universe is numbers between 1 and 10. So A is 8, 9, 10. So this guy is 1, 2, 3, 4, 5, 6, 7. And then if you want to know what's the intersection between AC and B, it's easy. It's actually just equal to 1, 2, 3. Equals B. So remember, intersection, it's what's in this and in B. So that's just B. Yep. So just to be clear, that's when I'm talking about this guy, I'm talking about the answer. Therefore, 1, 2, 3 equals B. Again, as I said, I'll write this out nicely. It's pretty terrible writing on this thing, but make do. So this guy, what's the product space? What's the Cartesian product between these guys? So we should have a bunch of tuples. So elements of A cross elements of B. So remember, A up the top is 8, 9, 10, and B equals 1, 2, 3. So A in the first place, 1, A 2, A 3, This will get tedious pretty quickly. 9, 1, 9, 2. I made you guys do all this, so I have to do it too, just to be fair. And then last one is 10, 1, 10, 2, 10, 3. Cool. Bit laborious, but we're there. So this guy, hopefully notation didn't throw you. This is the power set of B. So remember, power set is the set of all subsets. So B equals, I'll just write it out again, 1, 2, 3. So P, B. Oh, I'm tapping on the keyboard, sorry guys. It's going to be always null set 1. Remember, it's a set of subsets. 3, 1, 2, 1, 3. Go down the line. 2, 3. If I miss anything, guys, please let me know. Remember, order doesn't matter for sets. It matters for tuples, but it doesn't matter for sets. So you just got null set, set containing 1, set containing 2, set containing 3, 1, 2, 1, 3, 2, 3, 1, 2, 3, which is B again. Okay, so this guy, what is the cardinality of Yep. Oh, that, yeah. So if you didn't write it out, so for the question in the chat, if no one's looking at that, is the product space just the definition? I'd be happy with the definition. You probably should write out what A is and B. You know, that's safe if you didn't get it wrong. It's correct because that's the definition of the product space. But yeah, should be okay. We'll see. We'll see how the market feels. Yeah. So again, cardinality of the power set of B. So if you got the one before it correct, you're easy. 1, 2, 3, 4, 5, 6, 7, 8. Should be 8. Or type 9. 4. And you know, you have this result that it's 2 to the power of the cardinality of B. So if you want a bit of error checking, so cardinality of B is 3. Yep, it's got 3 elements, 1, 2, 3. So that's that notation. But the answer is 8 anyway. So always a good way to have 2 ways to check a thing in case you got it wrong, especially when you're in a test and you got nerves. Remember it well. Okay, so try and get going on to the next one. Any questions about that? Hopefully that was mostly just notation. Okay, so I should check from the question. Can everyone confirm that they've submitted by email in the chat or online? If anyone hasn't, please do it now. Please say if you haven't, yeah. Okay, I'll take that overwhelming silence that everyone's good. So continue. Okay. Cool. Right, so hopefully the first part was nice and easy, just definitions. Hopefully the whole thing was nice and easy, but sometimes you can get caught out. So truth table for the above expression. Okay, so it's always good to break these up into little bits. I'll draw some lines in a sec. So we're going to go A or B. And I'll do another one for A and B. Then I'll do another one for not. Sorry, I don't have the little sideways squiggle on my keyboard. Okay, James Kelly sent an email that didn't have the correct format and title. Hopefully that's okay. Should be able to work through for James. Okay, so we're going to go not. I'm just writing this all out, so we've got it in nice format, and then the whole thing. So this one, I won't do that. A or B or not A and B. Okay, I get a bit of a pen so I can draw a table. Cool. Okay, cool. So we keep going. Sorry, getting distracted. So we're going to go the truth values of it. So all the different possible values of this. So we're going to go true, true, false, false. I just made it. It's pretty sketchy there for a second. So we're going to go true, false, true, false. So we've covered every combination for A and B. So or should be pretty simple. Let's try and get this all on one line. As I said, I'm going to write this up nicely for you guys because I feel bad doing this on this thing. It's all very interesting. So A or B. So that guy's true. If A is true, B is true, or should be true, 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 and the only one that false is the bottom one. When we do and, we get true, false, false, false. So we're going to do the not of this guy. This is all pretty mechanical. And then what we're trying to do is the or of these guys together. So what we should get, if I didn't make a mistake, is false, true, true, false. Ta-da. Okay. So bonus question that you don't get any marks for, you can talk to me now. Does anyone know what that expression is called logically? That's a particular logic gate. Hey, fantastic. Cool, it's an XOR, exclusive OR. And that's that, you know, it's only true when it's true or false or true. So that's why I said using only ands, ors, or nots, because you could have just gone, it's XOR is equivalent to this guy. This one's going to be a little bit hard on the marker, because you could do anything. If I copy this expression, yeah, there's lots of ways you could do this. If you're a bit pain, you could just go not, done. That's an easy answer. If you're a bit of an annoying person, you could do that in front. Same, you could do that just in front of any logical thing. You could just go not A if you wanted to. You could also go, I'll keep that there in case anyone's interested. Another way of writing it is you can do it. You could do A and B, A and not B. Sorry for using the exclamation mark as a not. It's a little confusing, but I don't have the character, but I'll write it up properly for you guys. And B. So if you want to, that's another one that's equivalent. Remember, you show logical equivalence by doing the truth table. So that's great if you did that, but so you've always got to justify what you're saying. So hopefully I didn't get either of those wrong. Yeah, you could have come up with a million things for that. It's going to be fun for the marker. So always good life advice to make life easy for the person who has to judge your work. You can always show rather than just telling. It's always better. Cool. So again, this one's another one that's going to be fun for the marker. Because I said prove, I didn't say how to prove this. Hopefully I said it enough in when we're going through the reader in one of the previous lectures. Like if you see something in this form, the first thing that goes beep, beep, beep in your mind should be to prove it by induction. It's always probably the easiest way, but you know, if you're clever, you might have done something different. So be interesting to see if anyone did do anything differently. It's a pretty easy one. So again, I'll do a nice version of this. I'll do a very sketchy, dodgy version here by induction. So when n, so we prove when n equals 1. So when n equals 1, left-hand side I'll just write sum to 1 there. 2 minus 1. I really want to do the sum notation, but I'm going to struggle with the pen I've got. I'll try this. So, no, I'm scared this is going to go badly. Sum I equals 1 to 1 of 2I minus 1. That's really terrible. I will write this up for you. Equals 2 minus 1. And go over here. Hopefully we'll see your right hand side. That really didn't work, did it? So right hand side equals 1 squared equals 1. So it's true for the n equals 1 case. Then we assume it's true for k, which is basically just rewriting the expression again. And then we want to prove it's true for k plus 1, the inductive step. So again, this is going to be awful to write, I'm sorry. So what we're going to get, I'll try my best, guys. So we're going to go, we can go the sum from I equals 1 to k plus 1 of 2I minus 1. It's terrible. So this equals I minus 1 k plus 2k. Not going well. I'll write that in text. This is really difficult. Getting a nice pad to write on electronically is not really working for me. So we'd get 2 times k plus 1 minus 1. Sorry, guys, I'll continue on over here. So up here. So that first part, this first part here, is the bit we assumed is true. Okay, so we can rewrite this guy as, go up here, sorry guys. So that is k squared plus, again, this thing down the bottom, 2 k plus 1 minus 1, which equals k squared plus 2k plus 2 minus 1, being laborious, is 2k plus 2k plus 1. Binomial thing again, which equals k plus 1 squared, if you expand that, which is the other bit. So it's terribly nasty handwriting there. I'm really sorry about that. That's really awful. But again, and remember then when you're doing induction, hopefully you got a good example of it doing your assignment. You prove it's true when n equals 1. So it's pretty simple. It's 2 times 1 minus 1 equals 1 squared. Good. Assume it's true for k, and then prove it's true for the next step. So we just basically take one of those sum terms out, which is the next one, and then prove that that equals k plus 1. If I did, hopefully yours is neater than mine. I feel really bad about that. It's shameful. Okay, clear? Hopefully clear. Now I'd be interested to see, did anyone do it a different way? If anyone's brave. Did they try a direct proof or Something else? No one's going to say. Okay, cool. That's the easy way. So anytime you get an expression like that, just go. If it says prove something with a finite sum, you go, yep, induction's the way to go. Later, you'll get an infinite sum up there. So that'll be fun. That's where you'll be going next. Okay. Hopefully this one wasn't too tricky. It seems a bit simple. Some of them are actually a little bit nasty. So again, we've got consider the exponential function f maps from the reals to the reals defined by f of x equals e to the x. This is our friend exponential function, not our friend with coronavirus, but seems to be going okay around the world in different places. It's a good thing to think about. It's definitely not exponential in Australia. It's decaying exponentially. So what's the domain of f? Anyone? Everyone? Who's brave? The reals? Yep. Funny R. I'll just say R, but you know this one, this guy up here. So it's all in the definition. So that should be nice and easy. So that's this guy. Codomain, going from the reals to the reals. So next one is R again. That's just in the setup of the function. There's nothing special there. This one's harder. There's lots of scope for answering this very well, but like someone was asking, you know, if you just say the answer, how you go, it's sort of fine to just say the answer as long as you're correct. The problem with saying just the answer is when you're wrong. So this is a good lesson for your actual data science careers. Like always explain, because like even if you're last, you know, you're building this chain, this story, what's the answer? Then this can be actually quite hard to answer properly, but you would have seen the picture, exponential function, and it looks like I'm trying to draw. Exponential function's this guy. Looks like this. This is the guy. Drew that badly again. X and f of x. So this guy maps from all the reals to just the positive reals. So someone, yeah, that's an excellent answer in the chat. Yeah, R plus, positive R, x greater than 0. Yep. It's how you define it. So y belongs to R. So I'd write that in set notation. X, so y, say, such that y element. Yeah, I really wanted to write that with set notation. You realize how much you're missing. Give it a go. Give it a go. Please don't laugh at me for my terrible, terrible writing. So we'll go. Y is an element of the reals such that y is greater than 0 is a good answer. Finding it in terms of a set, I'll write that up properly. Yep, positive reals. You could have written R plus 0 to infinity as a you could do a little thing. I don't know if you guys have seen that stuff, so probably better off not to do that. Okay, so is F 1-to-1 injective? Who wants to be brave for this one? Everyone's saying yes. Okay, cool. Why? It's actually a harder question, and it's like easiest way to show that. So yes. And again, what the definition of proof by contradiction, yeah, cool. But it's the result you need for contradiction that's the hard bit. And the property of exponential function that you really want to go is that it's something called monotonic. I'm saying a bit more. I wouldn't expect this in an answer because you haven't learned up to this stuff yet. This would be like, it's an increasing function. Yeah, it's monotonic. So if the property for an exponential function is if x is greater than x2, then f of x1, so putting that in brackets, f of x1 is greater than f of x2. So remember that injective means that it's only got the same value if x1 and x2 are the same. So you can use this result to show that. Okay, if you wanted to give a good answer, you could just look at a picture and go, yep, it's 1 to 1. It's pretty using intuition. Okay, so is f as it's defined onto a surjective function? Where did people go for that one? Yeah, cool. And this is one, so it's not surjective as it's defined. So I'm being a little bit of a tricky bugger. And I said it's from the reals to the reals because you can't go from negative numbers. You can't map to negative numbers. There's no value of x such that, say, f of x equals minus 153 or whatever. Any particular number you can go, well, you can't get there. It's only going to these values over here. So it's not onto the whole. The codomain is not the same as the range. So this sort of answers your next question. So it's injective, but it's not surjective. It's invertible if it is injective and surjective. So the first answer is it invertible? No. It's not invertible. What's a simple redefinition of f that will make it invertible? So by redefinition, I'm talking about this function definition at the start. Got this guy. So anyone want to hazard a guess how you'd redefine that? Hey, good work. Yeah, so you just put a little plus up here. So just here, you just go R to R plus. Because we just said that, well, that's what the codomain is, and it's 1 to 1. So, yeah, you can do a simple redefinition to make it invertible by changing what, you know, where it's going to. Okay. That's it. Any questions about that as it is? We went through that much quicker than I was expecting, so I'm really happy about that. Got actual time for questions. So yeah, logarithm is only defined if it's positive. That's the whole thing. So the inverse, sorry, answering a question in the chat without saying what it is. So can you take log e to the x? It's like, yeah, that's what the actual inverse function is. It's the logarithm, but that's, again, that's the same thing. So yeah, it's only defined on this range. So you need to change the output side of the function definition so that it becomes invertible. Again, yeah. Any other questions from anybody? So I rocketed through it, which is good. No. So it sounds like everybody's okay with that. Hopefully it wasn't too traumatic. Doing quizzes are always a bit interesting. Wrong title is okay. I hope it's okay. I'm not actually doing the marking for this one, so I can't say definitively whether it's going to be okay or not, but I think it should be okay. A little bit of fluff on, a little bit of mistakes when you're nervous and stressed is okay. Usually people are pretty forgiving of that stuff. As long as you got it in before the time, that's the big one. For the right email address. Okay, so where do you guys go from here? So as I said, this is I'm a little sad because it's my last time with you guys. Back to just working as a data scientist again. So a little bit of fun doing this. So yeah, I know. Oh, sorry, did I write the wrong thing to Aiden? Yeah, sorry, I'll write up the correct answers, Aiden, so just make sure I get that right when I do it. It's probably a bit silly. So what do we got? codomain, range, codomain. Yeah, so it's the range. So codomain is in the definition. So we're going from here to here. So maybe I can share in the reader. Again, go to the definitions. If your maths is always definitions, look it up. I always get things wrong. I always feel sorry for people doing exams because it's pretty tricky to be correct all the time. And it's not quite how you work when you're actually working. You've always got time. Yeah, so okay. Yeah, so codomain is just the set it's mapping onto, Aiden. So that's the range that you're talking about. Yeah. I'm just looking through the notes to make sure I didn't do a fluff because I'm stressed too. We got a question in the comments. What does invoke PMI mean in homework 2 comment? Someone else asked me that in a private message. I didn't do the marking for the assignment, so I can't say definitively. I'm saying it's invoking the principle of mathematic induction. So okay, so you need to really say that you're invoking the principle of mathematical induction. So that's an assumed result you're using. This is me guessing what's on your assignment marks. I can't say. When you're doing a proof, you need to say all the things you're using. If you've got a previous result you're going to use, I'm going to use mathematical induction to prove this. So you need to be explicit. It's probably what the comment's saying. If you've got any specific questions, I'd forward them to Yoni, just to be sure. Yeah, so you're going to get a message, really. I got a thing from Yoni saying just some bookkeeping stuff. So students, you got a message. This message will come about assignment 3 in the end about the tutorial. And you're going to continue on with Hamid on the course reader. So you start on section 5. You're going to do some cool stuff where you start getting into calculus, which is the best good stuff. That's the stuff that will really help you with when you're doing the data science stuff. That's what all this stuff I've been talking about, all about calculus. Calculus is the thing. It's hard to overstate how important it is in mathematics, data science especially. Having a derivative, having a gradient when you're a big function, when you're a multivariate function, that's what you're going to use. It's a really big deal. Yeah, so hopefully I'll put this up here. My friend whose teacher sent this up. I hope our course wasn't like this. If you can see that. It's a little bit interesting time for everybody, teachers included, and me especially coming in doing this from externally. So hopefully it's working for you guys, and hopefully you're all surviving. Yeah. Well, we've got time. Does anyone have any general questions about like career stuff or anything I can help with there? Any questions about what it's going to be like on the other side once you're out of this thing? Take the silence as a no. Anyway, if you... Okay, I've got a good question here. I'm sorry, but do we need to know in depth about statistical methods when working as a data scientist? Yes and no. It's like, if you want to be a really good one, yes, you need to know the in-depth stuff. If you want to just get by, you can get by, but it's always better to know the details. Like, you can use, it's gotten to a point in data science where it's sort of easy to use these packages that do regression or whatever. You've got a question, you can set up the software. Problem is when it doesn't work, and that's often. It's either going to be a data problem or the state of the art isn't good enough to do the thing you're trying to do. It's important to be able to communicate your findings to a non-data scientist. Yes, a 10,000% to James. Yes, 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 yes. You need to be able to talk. If you're going to aim to someone, you should be aiming to business people and executives. So that's my job at the moment. It's actually spend a lot of time doing the maths, spend the rest of the time going and talking to these scary CEO people and C-level executives about, this is what's going on in your company. This is, you know, and being out there, they're a business background. So I don't know if you guys have business backgrounds. The things, you're trying to cross a big divide there. It's actually quite hard. And it's quite a differentiator if you're good at communicating things simply in a non-misleading way. I'd say machine learning depends on the part you're in, Aidan. Data scientists split into 3 areas, I'll say. There's the bit that's like, lost my train of thought. Traditionally in business, you'll have people who do analytics, which is like making pretty dashboards and showing what's going on within a business, which is really important. Then you got answering questions bit, which is the machine learning part. And then you've got another bit, which is the data engineering part. Data engineering is more like being a software developer who works with big data sets and working with, typically it'll be some person who's gone off and done lots of heavy duty machine learning. So I don't know how much of that's going on in Brisbane, but that's going to become a big thing. And I know in the States and stuff, they get paid quite well. Middle one is the ones who use machine learning. It is a big part. For me, it's a huge part. I'm that sort of data scientist where I'm sort of cross between the last two. So I'm doing a lot of the, you know, building algorithms, running them at scale, all that sort of stuff. And what do I enjoy most about it? I'm a big maths nerd. I love thinking about the problems. That's for Shaquille. It's quite fun. So the company I'm working for, I get thrown into another business and working out what's actually happening within their business just from data. And it's quite difficult at times. You'll learn a lot about how terrible the state of people's account keeping and things like that are. Usually it's very good about anything to do with money or anything to do with labor. Any other part of the business, like, you know, where are the cars that we own? Who knows at any point in time? Most companies you will encounter, especially medium-sized ones, they don't keep track of any of that stuff. And so if you're trying to say like, oh, how far have people been driving? When are the cars going to break down? It's like you have to use tricks and backdoor stuff to work out what's going on. I actually really enjoy that detective side of it. Have you ever dealt with data you felt breached people's privacy? Usually they're pretty good at setting up the arrangements for when you're dealing with that. So as I said, the last place, I probably told you guys a couple of times, I worked in remote sensing. So I worked at a place that had a photograph of everyone's backyard. But you don't ever look at it at that detail, and you have rules around how you're allowed to interact with it. You keep that mental mindset that you're detached, you know, and they're never that high resolution, and they're usually boring. So it's actually a good question, James. It's one of those careers where you will end up having to be pretty moral. It's good to have, you know, like engineers have a code of conduct. I think it should be the same in data science, because there's some things that, you know, you can quite easily wander off into some murky territory. And for Daniel, did I study data science? Oh, I'm too old. Unfortunately, I'm too old. It wasn't a thing when I learned it. It didn't really have a name. My background is mathematics, and I got into engineering control theory and signal processing. And there, signal processing in particular is a big precursor to data science. A lot of the guys I know who are data scientists who are old like me, started in signal processing. Actually go to a IEEE signal processing meetup when it was on. I'd encourage you guys. I'll actually share a link with you guys if you want for when it comes back on. You can meet some people who are experienced data scientists around Brisbane. So if nothing else, it would be good for, like, if you're trying to get a job, you can go and talk to some of these people. Yeah, so I know, sorry, Daniel, I'm too old. It's good that it's a formal qualification, because, you know, you guys are studying it with this, you know, with a good set of material. Software can be a bit like the Wild West when a new thing pops up, and you get people who say they're a thing and they've never done anything about that thing, and business people often can't tell. So it's sort of a bit of a worry, but it's good to have a formal background and you're learning good stuff. So actually quite impressed with the course material for you guys. It's really good. Anything else? Thank you very much for putting up with me. Yeah, dinner time sounds good. Good luck, guys. Good luck with the rest of your course. Please feel free to get in contact with me. You should have my email and a LinkedIn account on the page if you want to connect with me at any time. I'll be happy to talk to you guys. Okay.